Alright, so in this video I'm going to talk about hash maps. So in my last video talked a little bit about the maps. This is a continuation of that video. So in this video I'm just moving on to the next topic, which is a hash map. So as you can already see on the screen, I already have a hash map created and I added a bunch of values here to the map, and in the end I'm printing them out. So let's see what we get on the output console. So if you notice closely, the order of these values printed on the console is different from how I added them when I created the map. Well, the gray parrot is printed out first, while I added tabby and poodle before the gray parrot. And tabby and the poodle is printed last here. So why the order is messed up? Clearly, it's not the natural ordering, which means it's not ordered alphabetically by the key or the values. So how is this order defined? Means how is it random? Is there a certain order to it? So before I explain you, before I get into that, let me explain you how a hash function works basically. Since a hash map uses a hash function behind the scenes, we need to understand this first. So think of a hash function as a black box for now on, which takes an input string and produces the output hash. But there is a certain correlation between this input and the output hash produced. So the first condition is the hash value should be unique, which means for two different input strings, the hash value should always be different. In case it's the same, then we say the collision has occurred for a hashing function and it's no longer a hashing function. So the second condition it needs to satisfy is the output of each conversion should be different, which means is also the output of each conversion should be same. So no matter how many times this input string passes through the hash function, it should always produce the same output. So that is the second condition. The third condition is the conversion should be fast enough so we can use it in our programs so without slowing them down. So that is the third condition. So once a function satisfies all of these three conditions, it becomes a hash function. So now let's see how this hash function makes the hash map store the values, key values in memory. So think of this as a hash map key set and these as the keys in the map. And let's say ABC, this is the memory location and this is the hash produced by this key. In reality, the hash will be much longer and much complicated. The hash might also have some alphanumeric characters. But for simplicity, let's say ABC has a hash value of 3, XYZ has a hash value of 97, and JKL has a hash value of 9. Now, a hash map might be using a modular function behind the scene to store these values in the memory location. So how a modular function work is, a modular function produces makes you add the values in a round robin fashion, which means let's say I take a modular function %8. So after it has added the eighth value, which is 7 since I started from 0, it begins again from the index 0 and go on. So let's say there are 100 values. They will keep iterating one after another and keep storing in the different memory location based upon whatever index is produced by this modular function. So now let's see. ABC having a hash value of 3, then 3%8 when it passes through the modular function produces a remainder of 3. So ABC will go at memory location of 3. XYZ having a hash value of 97 produces a remainder 1, which goes here and is stored there. JKL also has a hash value of 1. So how do I store it there? So in that case, a hash map creates a collection here. It could be a collection or an array list or some other type of data structure. How it wants to store it could be a linked list too. So first it's gonna store XYZ because it was first, and then it is JKL. Think of it as a drawer in your cupboard where you have some files. So you store one file after the another in the order you get it in. So this is how it stores value. So that is So why the order? If you see, the order is different. ABC was added first, and since it had a hash value of 3, it went to 3, but XYZ went to 1, which is before 3. So in this way, the ordering of these keys and values become different behind the scenes. So that is why this order is different. So another question is, can you access this hashing function and implement your map? Yes, you can. All you have to do is create a class, implement the map interface, and then use the hash code method. So if you see, if I take my key from my map and run a hash code on it, it's gonna give me some hash value output on the screen. So hash value for this one is the one on the screen. Well, it's a long value, so I'm not gonna say it. No matter how many times I run it, it produces the same value. I'm not sure what modular function is done behind the scene, or is anything done to this before it is running through a modular function. So like I can do a bitwise shift before applying my modular function to it, or I could multiply it by some values or do any manipulation over it before I um, use this hash code. So in this way, a hash map stores value behind the scene and never to rely on the order you added the values in a hash map. So yeah, that's it for this video. So meet you in the next one. Bye.